Hello, everyone. Can you hear me okay? Can you raise your hand if you can hear me? Okay, cool. Thanks. This is a really good setup, by the way. Like I can see the room from the behind, which I never had this in an online, in a conference where I'm speaking online, but I can see from behind. I cannot hear, so I don't know how questions will work, but I can see the chat, in the online platform. So maybe you can ask questions there and I can answer there. And also people in the chat, if you are following online, please let me know if you can hear me. If you can type something in the chat, that will make sure that everything is set up. But let's get started. So my name is Mete Atamel. I am a developer advocate at Google. I'm based in London. And today I want to talk to you about open standards for building event-driven applications in the cloud. My slides are already on speaker deck at this link. So if you want to get the slides, they're there. And the things I'm going to show, I have a couple of repos. They're on GitHub. So everything I show today, the code and the slides, they're already out there. And I'm going to share the links at the end of the presentation as well in case you want them. Okay. All right. So, and after today, if you want to reach out to me, this is my Twitter. So feel free to follow and send me any questions or any feedback you might have. All right. Before I start, I work for Google Cloud, and we have this Google Cloud Innovators program. It's a way to connect with Google Cloud, basically. So if you join, you're part of this program, and then you can get credits and you can get some learnings and certifications and things like that. So if this is something you're interested in, feel free to scan and join. And again, the link will be shared at the end of the presentation. All right, so let's do a little bit of introduction to the topic. So let's imagine we're building an event-driven architecture. And let's imagine this is an order processing system. So you're trying to sell something and you have multiple services that kind of handle orders from customers. Now, let's imagine you have a front end. Typically on Google Cloud, you are using App Engine for front end, so that receives the order. Then you have a payment processor running on Cloud Run, which is a container service. Then maybe you have a shipper function, which is a cloud function. And maybe you have a notification service that notifies the user when the order is processed. Of course, in a real-world application, you have many more services, and it's much more complicated. But I'm simplifying here. And this is event-driven, meaning these services, they don't communicate directly. They don't call each other directly. They communicate indirectly with events. So the front end receives the order. Then when it's done its part, it will emit an event, this order received event. This typically goes to a message broker or event bus. Then the message broker figures out who is interested in this order received event, and it will route that to the payment processor. Then payment processor will do its payment processing. And once it's done, it will signal to the rest of the system that the payment is done. So it will emit this payment processed event. And then this continues. So this is event-driven because services are communicating via events. And the key thing is that it's loosely coupled. The services, they don't know about each other. They don't care about each other. If you need to add a service, you can easily add that service without having to change the rest of the architecture. If you need to remove a service, you just take it out, and the rest of the services should just work, right? So that's the kind of beauty of event-driven architectures, and that's why people kind of use them for loosely coupled kind of architectures. But in these event-driven architectures, you need to decide and communicate a couple of things. First, you need to decide on the envelope of the events. So the events, they have two parts. One is the envelope. So what kind of information do you use to route that event to the destination? And the other part is the data part of the event, the actual payload that you're sending. So data is usually custom to your application, but the envelope, you need to kind of decide that, what information you're going to use and how you're going to use that information to route your events. And the second thing that you need to decide is which service publishes or subscribes to what events, right? Because in event-driven architectures, some services publish events, some services receive events, and some services do both. They both publish and receive events. So you need to decide on that, and you need to somehow communicate that to the outside world, so people who are trying to use your services, they know how to reach to your services. Do they publish a message? If so, what kind of message they can publish? Or do they subscribe for messages? And if so, what kind of messages they can expect, right? So we need to decide on these as well. And the summary of my talk is that Cloud Events defines an envelope for events that you can use. And Async API helps you to document event formats, and it also helps you to document which service publishes or subscribes to what events, right? So these two projects, Cloud Events and Async API, they kind of help for these two things that we need to decide. And that's what my talk is about. So first, let's look into Cloud Events. Now, before we get into Cloud Events, let's again ask the question why we should even care about Cloud Events. And let's take a look at our event-driven architecture again. So in event-driven architectures, at the very high level, you have some event sources emitting some events, and you want to send them to some event destinations, right? That's fundamentally what happens. Now, of course, there is going to be something in the middle that first route these events. So you need a way to kind of take these events from sources to the destinations. But you also probably want to do more than that. You probably want to filter some of the events. Maybe you want to enhance some of the events. So there's a little bit of middleware that sits in the middle doing this routing and enhancement and filtering and so on and so forth. But in real world, you typically have multiple event sources coming from multiple different event mediums. So maybe you have an event source publishing events to a Kafka topic. Maybe you have another IoT kind of event source publishing using MQTT protocol. Maybe you have another event source running in the cloud and publishing to Google Cloud's pub subtopic, right? Now, all of a sudden, your middleware gets quite complicated because now you're dealing with multiple protocols, Kafka, MQTT, PubSub. You're also dealing with multiple event formats. So maybe your events are going over JSON, but maybe you want to use something more efficient like protobuf or Avro. And your events, they have their schemas. So you want to capture those schemas and you want to kind of communicate those schemas. So this middleware now, it has to do a lot of things. It has to read events, write events, and route events with using all these different formats and protocols and schemas and so on and so forth. So it becomes quite difficult when you have so many different formats and mediums. So Cloud Events, it's an open source specification for describing events in a common way. Okay, so that's what it tries to do. It tries to give you a common way of describing all these different events coming from different places. But not only that, it also gives you SDKs to read and write Cloud Events, right? So it's not just specification, but also code that you can use to read and write events. Now, it does this by defining a minimal set of context attributes. So these context attributes, they're basically the envelope of the event that describes how your event should be routed. And then Cloud Events, they also have this data field or data-base64 field where you can put pretty much any kind of event payload you want. So that's the part where that's the information that you want to send basically, and that lives under the data field. So that's what Cloud Events is. And let's actually take a look at an example. So Cloud Events, they have two different formats. One is called binary mode. And in binary mode, so here's an example of a Cloud event that I'm sending using just plain curl. And you'll realize that there's some headers. These are HTTP headers. And this is the body of the event. And Cloud event is basically, in binary mode, it's just a number of special headers that you add onto your payload. And then that kind of turns into a Cloud event. Now, first, the content type determines the mode of your Cloud event. So in this case, application JSON means this is a binary mode Cloud event. Then you have some Cloud event specific headers, and some of them are required, like the spec version, type, source, an ID. So this basically says what kind of an event is this, where is it coming from, what's this unique ID, the basic things that you expect. Then you can add time and subject as optional fields if it makes sense for your use case. Then you have extension attributes. These attributes, let's say your application needs some special attributes to route these events, then you can add them as extension attributes. And then you can use these extension attributes specific for your own system, basically. And then finally, you have the body of the event as data. So whatever you want to send, you send in the body. Now, binary mode, it's good for receivers unaware of cloud events. So let's say you're a receiver, but you don't understand cloud events yet. It's good for that because everything is in the headers. So if I don't understand these headers, I can just ignore them and I will still get the payload. Okay, so that's what people typically choose binary mode for. Now, the secondary mode of cloud events is called structured mode. And in structured mode, now this is the same event, but it's sent in structured mode. And you will see that there's only one header. And this header, it says Cloud Events JSON. This says that this is a structured mode event. And then the rest of the event is basically in the body of the HTTP request, right? So you have the spec version, type and source and ID, just like before. You have time and subject as optional, just like before. You have the extension attributes in case you need something special for your application to route. And finally, the actual data lives under the data field because everything is in the body, so we need to have a field for the data. So that's where the data lives. And structured mode is good for if you have a case where you have multiple routing hops or multiple routers. Sometimes it's better to have everything in the body because routers typically don't touch the body of the events or requests. Whereas if you have cloud events in the headers, then if the router doesn't understand it, sometimes it can drop your event. But both binary mode and structured mode, they're equal, and you can pick and choose whichever one you want. So that's what cloud events look like. But cloud events provide more than just a format. It provides different event formats. So you can use JSON by default, but you can also use protobuf, arrow, and there's an XML draft. It provides bindings. So how do you send the event over the wire? Typically, it's HTTP. But if you want to use AMQP, Kafka, or MQTT or others, it's possible. You have SDKs in different languages. So these are the list of the languages. So you can just go to the language of your choice and just have an SDK ready to read and write these events. And also, various cloud providers and vendors, they have their own libraries for cloud events because typically you would use a Cloud Event SDK to read the envelope of the event, but the data of the event is what you're interested in. And for that, you use the vendor's library to do that. For example, Google Cloud has this Google Cloud Events library to read events for Google Cloud. And actually, I have a repo. Maybe I'll just show this really quickly. In this repo, I show you an example. For example, here, I have some C# code. I don't know if you're a C# developer, but just to show you, I'm trying to read Google Cloud storage events. And these storage events, they're coming from EventArc, which uses Cloud Events. So they're storage events wrapped into Cloud Events. So what you do is you are using Cloud Event SDK to read the Cloud Event, and then you're using the Google Cloud Library for storage to read the body of that. So here, we create a formatter, and then in this formatter, we use a Google Cloud Storage Object Data Library. Then we read the Cloud Event. So this reads the Cloud Event from the HTTP request. And then we write out the Cloud Event information, like the ID, source, and type, and so on and so forth. And then the data field of the Cloud Event is already parsed into the storage object data because we used it in the formatter. So the actual data field is also kind of parsed already for us. So this is how you would do it, how you would use the Cloud Event SDK and also the vendor-specific Cloud Event libraries. And if you look at, for example, if you're a Java person, and if you look at Java SDK, depending on what kind of Java you're using, Spring or Kafka or whatever, or even basic HTTP. Depending on what you're using, there's different kinds of libraries that you can use, but the concept is pretty much the same. You have the Cloud Event, you use the Cloud Event SDK, and then you get the request, and then in Java, you would basically create what's called a message reader, and then from the message reader, you get the actual Cloud Event, and then you can just work with that. Okay. All right. But you need to keep some things in mind with Cloud Events. For example, there's batch mode in Cloud Events, which means you can set multiple events in a single request, but they are not supported in all protocol and SDK combinations. For example, JavaScript SDK supports HTTP and Kafka batch mode, but it doesn't support MQTT batch mode. Not all event formats are supported in each SDK. Again, JavaScript SDK supports JSON, but it doesn't support our or protobuf. Not all protocol bindings are supported in each SDK. Again, JavaScript SDK supports HTTP and Kafka, but it doesn't support AMQP, MQTT, or NATS. So the point is that depending on what you want to use, like batch mode, event formats, protocol bindings, languages, you need to basically go and check if that combination is supported, because there's a lot of combinations and not all of them are supported in all languages. And then there's three upcoming specs in Cloud Events. One is called Discovery API, the other one is Subscriptions API, and the other one is Schema Registry. And these are all about the lifecycle of events. So how do you discover the events? How do you subscribe to events? And how do you see the schema of these events? These are upcoming specs in Cloud Events, so we'll see what happens and how they will shape Cloud Events. And it's also interesting because in AsyncAPI that I'm going to talk next, they also do this kind of things. They also have a schema and stuff like that. So it will be interesting to see how Cloud Events and AsyncAPI kind of evolve together. Okay. All right. So as I mentioned before, you need to decide and communicate the envelope of the events with event-driven architectures, and a Cloud Events. It's a good one, I think. But we still need to answer this: which service publishes or subscribes to what events. So for that, let's look into AsyncAPI. Now, AsyncAPI, it's another open source specification. And it's a specification to define asynchronous or event-driven APIs. If you're familiar with OpenAPI, which is a way to define your HTTP or REST APIs, it's similar to that, but it's for event-driven APIs. And again, it's more than just a specification. It provides tools to visualize your specification and validate and make sure that it's a valid spec. It also gives you generators to generate code from your specification. So you can point your specification, and from there, it can generate some code for you. There are some things that you need to know about AsyncAPI, some main concepts. So at the top level, you have an application. This is your event-driven architecture event-driven application that you're defining. Then underneath, you need to define how do you get to that application. So that's done via a server. So you define a server, and a server usually has one or more channels that has a protocol to talk to. So let's say it's a PubSub channel with a topic, and you're using Google Cloud PubSub as the protocol, for example. Then once you have these basics in place, then you have your producers and consumers kind of sending and receiving messages. And then you also define what these messages look like, their schemas. So these are kind of the main concepts in AsyncAPI. But on top, you also have what's called bindings. Bindings allow vendors and cloud providers to kind of extend AsyncAPI and kind of make it work with their own systems. For example, Google Cloud has Google Cloud PubSub bindings, and that allows you to kind of use AsyncAPI to describe Google Cloud PubSub topics, for example. Okay, so these are kind of the main concepts in AsyncAPI that you should kind of know about. And one question I get is, I know OpenAPI for REST, but how does it compare to AsyncAPI? And actually, there's a good good link that explains this pretty well. So if you go to AsyncAPI's website, you'll see this comparison between OpenAPI and AsyncAPI. So at the top level, you have your application. So that's the info part. Then you have your servers and security. So that's pretty much the same between AsyncAPI and OpenAPI. But the difference comes in when you talk about the paths versus channel. Because OpenAPI it's a path-driven API where you're talking to you're defining paths and you're defining what you can do on those paths. So usually you have your path, and then what you can do on them is the operations. They're HTTP operations like get, put, post, right? And then what you can send is the requests, and then what you receive is responses. That's what OpenAPI does. Whereas in AsyncAPI, you don't have paths, you have channels. And channels, they have two operations, publish or subscribe. So you can either send a message to this channel or you can receive messages from this channel, right? And I already said it, what you send is not requests and responses, but they're actually messages with headers and payloads, right? So that's kind of the main difference between AsyncAPI and OpenAPI. Instead of paths, you have channels. Instead of requests, you have messages. And instead of HTTP operations, you have two operations, basically, the publish and subscribe. And the rest is pretty much the same. You define your messages down here, just like you define your requests here, so on and so forth. So that's kind of the main difference between AsyncAPI and OpenAPI. Now, what does an AsyncAPI definition look like? So this is the simplest AsyncAPI definition that you can have. So first you define your app under the info. Then you need to define at least a single channel. So here we are defining a single channel called hello. Then you need to define an operation on the channel. In this case, it's publish. So I can publish messages to this channel. And then you define the message, how the schema of the message, basically. So in this case, we are saying that we are publishing a message with payload type string. So we can basically send a string to this channel. So this is the simplest one. If we look at a slightly more complicated one, so here, this is slightly more complicated. So we define our application again. This time, typically you will have a server. You need to define a server to talk to your application. So in this case, it's an AMQP server with AMQP protocol. Then you have channels. In this case, we have two channels, a hello channel, where you can publish a hello message. And then we have a goodbye channel where you can publish a goodbye message, right? And these messages are defined here under components. So the hello message has a payload. It's an object that has a string and a send at field, and this send at defined later. And the goodbye only has send at, right? And then finally, the send at is defined down here under schemas. And here we're saying that this send at is basically a string, but it's a date time string. So you see how you define how you talk to your application via the server, what channels do you have, what you can do with those channels, and what kind of messages you can send to that channel. So everything is basically very well defined. And once you have that spec, you can use Async Studio, which is a browser-based tool to visualize and validate AsyncAPI files. Then you can use AsyncAPI CLI to work with AsyncAPI files. So you can basically use them to kind of validate your files. And I'm going to show you an example of this next. And then you can use generators for various languages and frameworks. Yeah, so with the generator, I should point out, if you go to generators page, you will see that there are generators for various languages. For example, generator for Node.js, for Java, Java Spring, for .NET with NATS. They're good as a starting point, but they're very limited. They cover very small subset of what AsyncAPI does. So it's not like you can take any of your specs and just kind of run through these generators and it just works. It just generates code for you. It doesn't. So it's very small subset of AsyncAPI where we have generators because it's very community-driven kind of kind of effort, but it's a good starting point. Basically, if you don't know how to kind of talk to your server, you can just generate some starting code for some basic use cases. All right, so now let's talk through an example of AsyncAPI and then look at some of these tools as we talk through it. And one thing that I want to talk to you about is the publish and subscribe semantics in AsyncAPI. As I mentioned, the operation that you can have on the channel is either publish or subscribe, but it can be a little bit confusing. What operation should you have, depending on whose perspective you're looking at? And let me give you some examples. Let's say you define a publish operation on a channel. From a user's perspective, talking to the channel, it means the user publishes messages to the server, right? So that's why it's publish. But from a server perspective, it means the server receives the message. Similarly, subscribe means that the user subscribes to receive messages from the server. But from the server perspective, the server publishes messages. And if you're coming from WebSocket world, publish is more like send and subscribe is more like receive. So depending on where you're looking from, it can mean different things. My suggestion is think of it from the user's perspective, then you don't get confused. Just always ask yourself, like, as a user, do I need to send messages, publish messages, or receive messages? And then that will kind of make the operation more obvious. And let's actually go through an example in this link to show you what I mean by this. So let's say we are building this very simple kind of architecture, right? We have an account service that sends messages that goes to the message broker in the back in the back, and the message broker routes that user signed up message to an email service, right? Now, if we want to define account service in AsyncAPI, is it a publish the operation? Is it publish or subscribe? Who says publish? If you can raise your hand. Who says subscribe? Yeah. So in this case, for example, the account service, we need to think about it as a user. As a user, am I publishing messages to the account service, or am I receiving messages from the account service? And I think the answer is we are not publishing. We're going to be receiving messages from it, right? Because the account service is the one publishing it, right? So that's why if we look at the account service definition, the operation is subscribe, because we, as a user, we are subscribing to receive messages, right? Because the account service publishes it, but we, as a user, we subscribe to receive it. So that's why when you define account service, you need to have the subscribe operation. So the definition here is, again, we have account service, we have the server, we have the channel. So this is where you get define subscribe to receive here. Email service, is it, am I receiving my email service? In this case, the email service to it, right? Email. So as I was explaining, for the email service, you need to publish to it. So that's why you define it as publish, and the rest of the definition is pretty much the same. And what you can do, by the way, you will realize that both email service and the account service, they have a lot of things in common, like the server is common, the message components are common, right? So what you can actually do is that you can define these common properties in a separate YAML, common YAML, and you can say, okay, this is my message, this is my server, and then you can go to your account service, and instead of defining them again, you can say, okay, my service is this service definition that I have in this common YAML, and my message is in this common YAML as well. So that way you don't have to define everything twice. Of course, you can put everything in one YAML if you like, but I like to separate things so you can keep them separate, but at the same time, you can refer to them in a common way. So once we have our definition, you can install AsyncAPI CLI, and you can actually validate. So for example, let me see if I'm in the right place. Yeah, so I can say AsyncAPI validate, and then just point to my YAML, and this will go through the YAML and kind of make sure that it's valid. I had some warnings, but no errors, so that means it works. And then once you have that, you can actually generate code from it. So you can say AsyncAPI generate. You can point to a template. So in this case, the template is AsyncAPI Node.js template. Oops, sorry. And then you point your YAML, and then you create a new directory, and then that's it. So let's actually do this, and I'll just change this to another folder. And now this will look at the YAML file, and it will kind of generate some Node.js application for it to from the definition. Now, as I mentioned, this works because I made sure that I have a simple enough YAML that works with this code template. But if you have something more complicated, it probably won't work because, as I said, the templates are very basic and they don't cover all the use cases. But in this case, I have the email service. This is the generated code. And then if I do npm start, it will start an MQTT server, and it's running. And then if I actually send a MQTT message to it, it's sent. We can see that that message was received. So it's good for some kind of like a startup code. And if you are a Java person, for example, let's go back to here. Let me remove this email service too. If you're a Java person, there's also a Spring template, and all you do is just point to the template from the YAML, and now this will generate Java code. Although this code, it didn't work on my machine when I tried because I don't have Java set up properly, I guess, or something else is going on. But anyway, at least it gives you something to start with. All right. All right. So now I think what I'm saying is basically that AsyncAPI gives you a good way of kind of defining your services, async services, and communicate that to the outside world. Oh, and I forgot to show you the Async Studio. One thing I want to show you is, let me see, where is that? Yeah, there's this Async Studio that I find really useful. So once you have your YAML definition, you can open Async Studio, which it can run. It can run both locally and also like in the browser as well. And let me see if I have, where's my earlier example? So let's say, let's take one of my, let's take one of my samples that I show you. Account email services. And let's take this account service. So we can take this, we can put it here, and then we get this visualization. Basically, it tells us our service, it tells us our server, and then we have our channel, and the channel and the operation on the channel is publish. And then you can even see the type of messages that it's accepting, like display name and email. And you can even get an example of the payload, right? So this is very useful for kind of documenting and communicating what your services should get, right? So I find this quite useful. All right, so we covered all this, so let's skip back. And in the last 5 minutes, I want to basically talk about a couple of things. So I looked at AsyncAPI and I said it's great. I looked at Cloud, and I talked about Cloud Events, which is a common format for documenting events. But then I asked to myself, can I use Cloud Events and AsyncAPI together? Like, for example, if I have a service that's receiving Cloud Events or sending Cloud Events, can I actually document that somehow? And the answer is yes. AsyncAPI is flexible enough to allow you to do that. As a reminder, we have Cloud events that look like this. So this is the structured mode where everything is in JSON. So let's imagine a service kind of uses this mode. How do you document this in Cloud events? Well, in Cloud events, so this is the definition. What you can do is when you're defining your messages, here, I'm saying the payload is here, so the message payload. And then if you look at under this payload, I'm pointing to Cloud event spec. So I'm saying that this payload needs to have all of the fields that are defined in this Cloud event spec. So Cloud events, they have a separate spec for their Cloud events fields. So I can just point to that. And by that, I can use this in AsyncAPI, which is pretty cool. And similarly, if you go back, where's my, if you go back, sorry, I'm getting, it's here, okay. So if you go back, so that's the structured mode, but in binary mode, we have things in headers, right? So how do we actually document these headers instead of them being in the body? Well, again, thankfully in AsyncAPI, there's something called message traits. Message traits are headers that you want each message to have. So you can define a message trait here, and I did define it here myself because Cloud events, they don't publish their traits. But here I'm defining message traits. I'm saying these are Cloud events, these are the required ones, and this is how they should look like. And then when I define my AsyncAPI, when I define the messages, I can point to traits and point to my traits that I define. And by that, I'm making sure that all the messages that come to me, they have these Cloud events headers that I require, right? So that's really good and really flexible. And lastly, I also ask, okay, I use Google Cloud PubSub, but the AsyncAPI is open source. Can I use that to document my Google Cloud PubSub topics? And answer is again, yes. This is possible because AsyncAPI has the notion of bindings. So Google Cloud PubSub have special bindings for AsyncAPI. And when you define your channels, here I'm defining a channel. Under there, I'm defining a binding, and then this is Google Cloud PubSub specific stuff, basically. So here's the Google Cloud topic and the schema settings for that topic. Or if you need to specify any other Google Cloud specific options, you can do that under binding. So by having these bindings, that's also possible. And this is not only true for Google Cloud, but also for many vendors. They have their own bindings. Kafka have their own bindings and everything. That way you can use AsyncAPI in a bunch of different settings, basically. And I really like that. All right, so that's all I wanted to say. So hopefully this was useful to you. If you want the slides, this is the link. If you want the examples I show you, they're in this link and in that link. And if you want to join to our Innovators program, this is the link for that as well. So thanks very much for listening. I see a question in the chat, so I'm going to answer the questions in the chat. I don't know if people in the room will be able to ask, but if there's a way to do it, let me know and I will be happy to answer. So in the meantime, let me look at the question. So someone is asking if AsyncAPI specification is like OpenAPI, but for asynchronous system, is there Cloud events equivalent for RESTful system to describe data payloads? Yeah, so basically they just asked, can I describe Cloud events in AsyncAPI? And I just show you that you can, yes. So that's totally possible. And just check my repo for some examples. The other question, how does AsyncAPI handle event versions? Well, when you define your services, you define your message payloads, and the message payload will basically show what the message should look like. If you need to have versions of those payloads, I guess you need to have a new version of your definition. So you will have another version of your definition, and then there the payload will change. I don't think the messages themselves, they have this version field or anything like that. You will basically have a new definition, async API definition, and that definition probably has some version that you add on to keep track, and then you will do it that way, I think. I don't think there's anything inherent in the messages themselves in terms of versioning. Okay, that's all there is to it in the chat. Oh yeah, I see there's someone in the room with a microphone. So if there's a question in the room, I can take that as well. No? Okay, well, hopefully this was useful. Thanks very much and enjoy the rest of the conference. Thank you.